I am Anil Kumar. Welcome to my series on compound interest and annuities. We'll discuss present value and amortization in this particular video. If you need to learn from me, you can always send me an email on the address given here. In this video, we'll talk about the timeline and the present value. We'll discuss how to derive the formula for present value. We'll take up many examples which you see in test papers. One of those important example is when you make an early payment, how much lump sum can you make? Compare the situation where we have 0% financing and an option given to you. And also, how do we make amortization table and read it properly, especially finding balance amounts. The formula, as you know, for present value is r times 1 minus 1 plus I to the power of minus n divided by I, where I is the interest rate per compounding period and n is the number of compounding periods. You can always rearrange this formula to find the value of r in terms of present value p. So we might write present value as p or as pv as the situation may be. So here is the timeline which you see, which we are going to discuss, and that's the amortization table, which we'll again discuss in the last example. Let's begin with the common terms being used here. So the very first one is the present value itself, which is normally denoted by letter P or PV. So present value of an annuity of n payments of R each at the end of consecutive interest periods with interest compounded at the rate I per period is given by the formula PV or P is equal to R times 1 minus 1 plus I to the power of minus n over I. Now what is amortization? Amortization is payment of a loan with regular payments of R, right? On calculators, you might find a function PMT. A loan of P is amortized in n equal periodic payments of R made at the end of each period by with compounded period interest rate of I is given by the formula R equals to Pi over 1 minus 1 plus I to the power of minus n. So that is rearranging the present value formula. Now let's try to understand how do we derive this formula also. So in example 1, we'll actually create a timeline and the present value will be discussed. The question here is, how much do you need to invest now? So whenever you say invest now, it means present value. So you need to identify whether the question is about present value or future value. How much do you need to invest now at 8% per annum compounded annually to provide $1,200 per year for the next 5 years? Draw a timeline to represent the amount of the present value. Correct? That's the question. So we need to find the equivalent present value of the expected amount after n years. This can be calculated using the compound angle formula itself, right? So see the timeline now. Let us say we begin now, we'll just call it 0. At the end, all the payments and the compounding period is end of the year. It is case of ordinary annuity. So at the end of the year, we want $1,200. First year, second year, third year, fourth year, and fifth year, we need $1,200. So those are the values which we need after first, second, third, fourth, and fifth year. Now those $1,200, what is their present value? This is what we need to figure out, right? How much do we invest now so that we could get those $1,200 in future? So the present value of those $1,200 is to be calculated. Now we could easily calculate this value using the compound angle formula. So amount is P times 1 plus I to the power of n. Rearrange, and when you rearrange, you get the present value, which is amount divided by 1 plus I to the power of n. Right? So that becomes the uh, present value from the compound angle formula for a particular value in future. Right? So the timeline shows the present value for each $1,200 with 8% per annum compounded annually for the next 5 years. The present value of each payment is first 5 of the geometric sequence with A equals to 1200 into 1.08 to the power of minus 1. Now see, the interest rate is 8%, right? 8% per annum compounded annually, correct? That is the interest rate. Now, if that is the interest rate, you could write decimal equivalent of 0.08, right? So if you put 0.08 here, so you get 1.08 in the formula, right? So when you put this formula, you see 1200 is what you need as the amount, divide by 1.08 to the power of n. After 1 year, 1. After 2 years, it will be 2, then 3, 4, and 5. So you get this geometric series in which, as you can see here, each term is 1200 over 1 plus 0.08 to the power of n, right? That is what each term is. So at the end of first year, if you need 1200, then this value of n will be 1. So you have a geometric series. Now in this geometric series, the first value a is indeed equal to 1200 divided by 1.08, right, to the power of 1, which you could write as 1200 into 1.08 to the power of minus 1, correct? And that is what is written here. So that is the A value. Now every time you are multiplying with R, which is 1.08 to the power of minus 1, that is 1 over 1.08. So to find the sum, that means add them all, correct? These are your first 5 terms of geometric series. The formula for geometric series is A times r to the power of n minus 1 divided by r minus 1, right? So in this case, A is 1200 into 1.08 to the power of minus 1. And then r to the power of n, r is 1.08 to the power of minus 1 to the power of 5 because we are compounding for 5 years, right? And then minus 1. And in the denominator, you have 1.08 to the power minus 1 minus 1. You can calculate this value. It comes to 4791.25. So that is how you could calculate the present value, right? So I hope this step is absolutely clear. Now, once you've done this example, let's try to derive this particular formula also. In example 2, we are going to derive present value formula. Let us consider an ordinary annuity where deposits of R is made at the end of each interval of n periods at the interest rate of I per period. Then amount in the account after n periods will be the sum of the series, right? Which is R times 1 plus I to the power of n minus 1 over I. Correct? Find the amount to be deposited lump sum now at the same compounded interest to produce exactly the same balance at the end of n compounding periods, right? That's the question for you. So we want to find the present value. So the solution for this ordinary annuity and the present value equation is compounded amount of the lump sum P deposited should be equal to the annuity, right? So the compounded amount is P 1 plus I to the power of n. which should be equal to r times 1 plus I to the power of n minus 1 over I. Now from here, let us isolate what P is. That is, we'll divide by 1 plus I to the power of n. So we get r times 1 plus I to the power of minus n. Now, you can actually open this bracket, distribute, that is, multiply this over the terms inside, and then what you get here is r times 1 plus I to the power of minus n times 1 plus I to the power of n minus 1 plus I to the power of minus n over I. Now these first two terms, they cancel, you get 1 there. So you get 1 minus 1 plus I to the power of minus n over I. So this becomes the formula for calculating the present value. Is that clear to you? Right? So we can say that the present value, if we know the recurring deposits or deposits per term, we know the interest per term and the number of terms, then we can use this formula to find the present value. So we actually derived this present value formula from the future value formula, correct? Now in example 3, the question here is, cost of a car is $35,000. After the payment of $5,000, the balance will be paid off in 60 equal monthly payments with interest of 4.5% per year on the unpaid balance amount. Find the amount of each payment. Now, how do we solve this? Well, since $5,000 has been paid, the amount to be paid is 35,000 minus 5,000. That gives you 30,000, right? So $30,000 is to be paid at 60 equal monthly installments with monthly interest rate of, well, divide this 4.5% by 12. So decimal equivalent is 0.00375 per month. Now apply the formula which we just derived in example 2. So the present value equals to r times 1 minus 1 plus I to the power of minus n, right, divided by I. The present value is 30,000, so we substituted value 30,000. We need to find the value of r. We know the interest rate is 0.00375 and n is 60. Substituting these values, we do get, calculating the central portion, as 53.639 R. So R is 30,000 divided by 53.639, which gives us the value of 559.29. So the monthly payment of 559.29 will be required, right? So many dollars. Now alternate method, of course, will be, you can rearrange the formula, and once you rearrange, you substitute the values. Okay, let's take example 4 now, which is, there are a couple of questions in this. So we'll say a situation is, Anil borrows 100,000 for 6 years at 12% annum interest compounded monthly. So we have a question of monthly interest. 12% will be divided by 12. So we'll get 1, right? So 0.01 in decimal equivalent. Now, part A is, find the amount of monthly payment needed to amortize this loan. B, find the amount of interest paid when the loan is amortized in 6 years. C, find the part of first payment that is interest and the part that contributes to reduce the debt. So whenever you actually make this payment, regular payment, part of it goes towards the interest and the other part goes towards the principal. Initially, more goes towards the interest than the principal, right? We'll actually extend this and also see what is there further. We'll take up 8th example, which is, after making payments for 4 years, Anil decides to pay off the loan. How much lump sum amount must he deposit to pay off the balance loan, right? So that is also a very interesting situation which we will look into. So let's begin with the question. So here we know present value is 100,000. Interest rate decimal equivalent is 0.12 divided by 12, which is 0.01, N, the number of compounding periods will be 12 into 6, right? 12 months, 6 years, 72. Okay. First, find the amount of monthly payments. So we need to find the monthly payments needed to amortize this amount. So R is equal to the present value into interest over 1 minus all this. Substitute the values in the formula which we just derived and then calculate. It comes to approximately $1955. Now, part B here is find the amount of interest paid when the loan is amortized in 6 years. So we know those are the monthly payments being made, right? And 72 of them will be made in all. So the amount which is actually paid is 1955.02 into 72. However, we had taken the principal amount of only 100,000. So if you see the difference, we get the interest, which is 40,761. So a huge amount of interest is actually paid whenever you are taking such situations. Part C. Find the part of first payment that is interest and the part that contributes to reduce the debt. Well, we know that the first payment is 1955.02. Let us find the interest actually. So interest is PRT. Now in this case, the total amount was 100,000. R is 0.01. So 1,000 is the interest. So 1,000 is the interest, and therefore from the total amount, you can see 1955, the 1000 is the interest, and 955.02 is towards reducing the debt, right? That is what the situation is, right? So interest is even more than what goes towards reducing the debt, correct? Now let's take the part D, which is same situation. After making payments of 4 years, so instead of 6 years, Anil decides to pay off at the end of 4 years. So after making payments of 4 years, Anil decides to pay off the loan. How much lump sum amount must he deposit to pay the balance amount? Now, there are many ways to solve this. Now, what you need to do is to understand that at the end of 4 years, what is the situation? How much amount is still to be paid? And that has to be paid at the end of 4 years. So we begin by calculating the payments left. So after 4 years, 24 payments are left. Payments for 2 years, right? 2 into 12. So that is what is left, right? So we have 2 into 12, which is 24 payments are left. These 24 payments should be paid, and each payment is of 1955.02, right? So that remains to be paid at the interest, which you know is 1% 0.01. So now let's find the present value for the same. So the present value formula will be used, which is equals to R times 1 minus all this. Substitute the values and calculate. So it comes to $41,531.25. So the payment of $41,531.25 is required to pay off the loan at the end of 4 years. Is that clear to you? So the key here is at the end of 4 years, see how many payments are to be paid and then find the present value of these payments, correct? So that is how you will do it. Let's take up the next example, which is compare 0% financing options. So many times, especially when you buy a car, you're given such an option. And so we have a very practical question here. A car dealer offers buyers of a Honda Accord a cash discount of 2500 off the 25,000 price, or 0% financing for 60 months. So there are two options for you. Option 1 is a discount of 2500. We know that the cost of the car which we're talking about is 25,000, right? And the other option is that you can actually get it financed at 0% for 60 months, that is 5 years, right? So those are the two situations. Now the question here is determine the monthly payment on the car if person chooses 0% financing option and finances the full amount of 25,000. So when you take the financing, you don't get the discount of 2,500, right? That is the whole idea. So you need to really compare whether the discount of 2,500 is better or just to pay, right? Okay, so let's first calculate the value which you're paying monthly for 0% financing. So the monthly payments, let's calculate that first. So the monthly payments on 25,000 at 0% will be, since we are paying in 60 installments, we'll divide the amount by 60. Clear, we get a value which is 416.67. So those many dollars are being paid every month to actually pay off the loan in 5 years, 0%. Is that clear to you? Now, look into the second case. Let us say you don't really have that money, but you need to borrow. You could borrow from somewhere else, right? That is the whole thing. You can borrow from somewhere else and take this discount of 2500. It's a big value. Okay. So if the person chooses the cashback option, their purchase price will be 22,500, because then you get this discount, right? So instead of 25,000, you're now limiting yourself to 25,000 minus 2,500, which is the discount. So you get 22,500 to be paid, correct? So that is how we get this situation. So, yes, this situation, correct. So now here, if the person chooses the cashback option, their purchase price will be 22,500, assuming that the person is able to get the financing for the full amount from a local bank at 4.2% per year for 60 months. What will be their monthly payments? Now, we have taken a very practical value of 4.2%. In fact, these days of COVID, you can get very, very low interest rates. Correct. So much lower than 4.2% is possible. Okay. Now, if that is the situation, you take a loan from somewhere else and then buy the car and also avail the discount. That's a good thing to do. So let's do that and work out the monthly payments now with this situation. Now, with the cashback option, the principal is now 22,500, and still you need to pay in 60 installments at the interest rate of this time, because the person is able to borrow the money at 4.2%. So 0.04 to divide by 12, which gives you 0.0035. Now let's use the formula to find the value of R, substituting what is known to us, that is principal and the interest and the compounding number of terms. We get the value as 416.41. So it is slightly lesser, right? It is slightly lesser than what we calculated earlier. So this is a better option. And it clearly indicates if we can borrow the money at less than 4.2%, then it'll be a much better deal. You get the idea, right? So that is how you should work out such situations, right? It gives you a practical idea of the whole situation. I hope you've understood this. So it is better to take the discount and get the car finance from some other place. Bank is a good option. Now, here is the last example which we'll discuss. Uh, it is about the amortization period, and we'll also understand how to create amortization table. Peter borrows $3,000 for 1 year, right? So for 1 year, $3,000 at 6% annum interest compounded monthly. Now, part A is determine the monthly payment on the loan to amortize this loan, to pay off this loan with installments. B, make an amortization table to show the portion of payments for the interest and the reduction of the debt, right? So we saw in one of our examples that initially the payments go more towards the interest than towards reducing the debt. But let's really see it, okay? And C is algebraically find the remaining balance after 4 months. Well, if you make a table, you can always read what is the balance after howsoever months you calculate, or we'll also see the algebraic method. Okay, so here is the solution. We know that the amount which is principal is 3,000, And the interest rate will divide by 12, the 6%, and get 0.005 decimal equivalent per term, period per period, right? And n is 12 periods. Okay, so R is calculated substituting the values in the formula which was derived earlier. We get the value of R as $258.20. So the regular payments of 258.20 is required to amortize the loan. Clear? This is a direct application of the formula which we had done earlier also. Now let us now see how do we make a table. So remember, we came up with this particular value that every month $258.20 is to be paid. Now it is kind of important to understand this number is rounded, and therefore the last installment will actually match up to pay everything, right? So it will be slightly different from this amount. So we'll assume the same amount and make a table now. Okay. So while making the table, which is shown here, here are the values which we are working with. We have a principal of $3,000, interest rate 6%, which is divided by 12 to get 0.005. Number of periods are 12, and we just calculated the value of R, or monthly payments, as 258.20. So in this table, we have number of payments, as you can see here, which goes from 1 to 12. So we have total of 12 payments, as you can see. And amount of payment are monthly payments are 258 everywhere. You can see this is a constant. So every month you pay this amount to amortize the loan in 1 year, right? So that is what it is. Now, what is important to understand is that we started with the amount which is 3,000 to be paid, right? So in the first year, what is the interest? We can calculate the simple interest, right, of this amount, and the column 2 gives you the interest on the amount left to be paid, right? Now, every time you make some payment, you find a reduction in the principal, so the amount balance will be reduced, and the new interest on that amount will be calculated, and we'll take away that to fill up the next column. And then we'll subtract from the previous principal to get the balance. Is that clear to you? So what we have seen here is that we have regular payments of 258.20. Interest is basically paid on the amount which was pending to be paid times the interest rate, right? 0.005. So this is what we are going to calculate. So this is represented in the third column. Now, once we know that this is the interest being paid, then taking away this amount from the actual amount, we know how much portion is going towards the reduction in the debt, right? So then you calculate the difference between previous to what has been paid as the interest. So we know that towards the debt this amount is there. Then you can deduct that and get the column filled up for the principal at the end of the period. You get the idea, right? So that is how we are going to work on it. Okay, now, so the table is created. Use the Excel sheet. We can substitute the formula there, and then immediately you get all these values. So what you notice here is the last column showing that at the end of 12 years, there'll be like minus 0.03. This is mainly because of the rounding, correct? So this has to be matched at the end. This is because of rounding. Is that clear to you? Okay. But I hope you understand how to create the table itself. So in the first column, write down number of payments. Second, what actual payments are being made. Then in the last, we'll begin with the amount, which is the principal, right? So which is 3,000. So calculate the interest on this 3,000, correct? So we just calculated what is 3,000 times the interest rate of 0.005, and it came out to be 15. So we wrote this value I, which is the interest, correct? Then you take away this interest from the amount which was paid. So that will be towards the principal, correct? So then you did this portion so that you know what deduction is being really made on the principal, and then finally take away this amount from previous principal to find the new balance principal, which is right there. Correct? That is how you'll do it. Now, from the part D was balance after 4 years in the present value of the remaining eight payments of 258.20. This is what we need to find, right? Let's go back to the question. We've done this, make a table. Now, we have to find part C, which is algebraically find the remaining balance after 4 years. Let's calculate this. So after 4 years, you can see that the balance is what? Let's highlight. So after 4 years, that is the situation, and we do see a balance of 2019.87, correct? So that is what comes from the table, but let's calculate it algebraically, right? That is part C for us. So balance after 4 months is the present value of the remaining eight payments of 258.20. So just plug in the values, right? We know each payment is 258.20. Interest is known to us. 8 are the number of payments. Calculate the value. 2019.89, right? Which is very close, just 2 cents difference because of the rounding. So we get that amount is to be paid after 4 months, right? Do you get the idea? So that is how we could actually do it. So I hope you understand and appreciate how do we work with annuities, present value, and amortization, right? I like you to go through this once again. And if you really like my videos and want to learn from me, you can always contact me on the email address given. Also, on our website, we have many important videos. You could watch them. Right. So with that, we come to an end to this particular series on understanding compound interest annuities, where we discuss present values and future values earlier. Right. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.